We are going to start lesson 70 with this question. Let's estimate the area found between the continuous function f of x and the x-axis between an interval a to b. How would you do this? I don't have standard formulas to calculate areas of curves, but we can certainly break this down into shapes that we're very familiar with and shapes that are easy to work with. I'm going to choose rectangles. And these rectangles that I'm going to draw will have a width of delta x, so they will be the same width but taking on different heights under the curve. Well, how tall should they be? You have options. You may choose to start drawing these rectangles from the start of your interval, and then draw the next rectangle of the same width at a distance delta x away from your first starting point, 2 delta x's away from your starting point, and so on. Notice how these areas of rectangles are larger than the actual area under the curve. So this is called the upper sum. On the other hand, you may also use the position of a plus delta x, as the height of your first rectangle. When you draw your rectangles like this, then you're going to have empty spaces under the curve, yet this is still going to be a good estimation of the area that you're looking for. Let's call this the lower sum. So we know that for sure the area between the curve and the x-axis in the given interval will be somewhere between these two sums. So let's summarize what we just said. Okay, we're taking a look at the upper sum. The area is approximately the sum of these rectangles, where we start the height of the first rectangle from a, then the next height is f of a plus delta x, f of a plus 2 delta x, and so on, up until the very last rectangle, which has a height of delta x before b, the end point, right? These are the heights, and then we multiply that by the width of these rectangles, which is delta x. We can certainly write this as a summation, and we can represent, the changes in the positions as xi. Okay. How do I make sure my area is accurate? Well, in the diagram here, I'm using 4 rectangles. How can I improve that? Well, consider the more rectangles you use, what will happen to these edges that stick out from the area? There will be less, right? So it seems like the more rectangles I use, the more accurate the sum or the area will be. As a result, we're really referring to the limit as n approaches infinity of this sum, and it is known as the Reimann sum. On the next page, you will actually carry out an investigation by taking a look at how you're going to calculate the area under the curve f of x. You can either follow the first link, which takes you to the GeoGebra Reimann sum calculator. You saw the screenshots on the first page. Or you can follow the second video, where you can learn how to create an actual program on your calculator to calculate the Reimann sum for you. Okay. After you finish your investigation, you can go to the next part of this lesson's videos to continue into the examples.